People, welcome back. Let me check the audio, guys. Do we have the audio? Are we fine? Do we have people on this live stream? Do we have people? All right, we do have people, but it's only 8 people at the moment. 10. All right, so it looks fine. It looks fine, people. So today on this video, as you can see from the thumbnail, we'll be doing question 2 of question of the test 2 that we did last block. So I'm gonna show you the question. So before I do that, here's the QR code. If you're not part of the WhatsApp group, that WhatsApp group, I have some information that I sent there. One of the information is the previous question paper that we're gonna do there. I shared the question paper and the memo as well, so you can able to download the question paper. There are links there that I sent yesterday for some people. I assume most people managed to download those links. And then if this code doesn't work, I also left the link this time around on the description of this video. You can go to the link and click on that description, click on that link, and then it will take you to this group. All right, so I'm going straight to the video now. I'm going straight to the question. So here's our question. So this question is a common question paper where it was written by the Free State and the Gauteng region. But anyone can benefit from this video because maths is maths at the end of the day. All right. So guys, comment there where you're coming from, the province and the college. I would really like to know how many people we have from different provinces and colleges there. So this was written March. Yes, it was written March 2025. So it was out of 60. But the one that you're gonna write here on the 16th, this year, this block, I think it's gonna be out of 70. So let me not waste any time, guys. Let me just zoom question 2 here. Like I said yesterday, if you were watching the video yesterday or you were in a part of the live stream, we did differentiation. So today we're gonna do integration. So I hope this time around we're gonna be quick. And the mic, guys, I tried to change it, but I couldn't get enough time. So I'm gonna try to be as quick as possible, guys. Right? Okay. So now let's start, guys. Do not forget to comment, guys, where you come from and your college as well, your province and your college. That would be highly appreciated. I really want to know where do people coming from, guys. Okay, someone say a golden king is greeting us there. Say greetings, sir. Before we start, can I ask something about the turning point? Because the answer we did yesterday is not the same as the memo. Yes, golden king, I told you yesterday that some of the answers on the memo, they are not correct. So I've noticed that as well. It is not correct how they factorize the x values. It was not correct, right? So unfortunately I cannot go back to it, but it's not correct. And even here on question 2, there is a question that is not correct there. So before you use the memo, guys, make sure you understand what you are doing there. The memo is just a reference, right? Especially when you practice, never use a memo, never rely on memo. Let me just put it that way. Even the question papers from the app, the final question papers, there are a lot of mistakes there, guys. So I'm not saying don't use a memo, but never rely on the memo, because we do a lot of mistakes when we type these memos. Mostly the mistakes are typos, right? We do memos, we hand in to the assistant, and then the assistant, they don't know maths, they just type what they see there. Sometimes they type a wrong number, and then everything looks funny. but that is incorrect, by the way. The turning points are incorrect there. So the correct one are the ones that we did in this video, yesterday's video. So let's just start, guys. Let's just start. I can see there are people from Gauteng, CJC College. We have KZN Coastal College, Devon campus. We have Free State, Golfit, TVET. Oh, we have people. We have people. That's great, people. That's great. Let's just start. Let's just start. Right. So I hope you guys are gonna ask questions, and please stop me, guys, if you see if I make some mistakes there. Right. Please stop me. I'll try to pay attention to your statements there. Right. So I'm gonna start with 2.1. Question 2. It's all about integration, guys. So I'm gonna start with 2.1. So this 2.1 here is actually a polynomial. I hope you guys can see it. Let me zoom it a bit so that we can able to see. It's a very long question, guys, and it's out of 9 marks, so it has lots of marks there, guys. Right? We have people from West College and EWC. Yeah, Katoras. That's nice. Yes, people, that's nice. We like it. We like it. Everyone is here. So let's just start. So I'm gonna rewrite this. I'm gonna try to copy it on the side, and then we solve it. So let me just zoom down, guys. So 2.1. If you don't have a question paper, you can join the group and download the question paper, or after here. So 2.1, what we have here is the following. I'm going to write it here. We have sigma, we have open bracket 4, and then we have cube root, right? X minus 3 cos, right? Cosec x multiplied by cot x, right? So let me just create more space, plus 3 tan x minus 2e to the power of, yeah, let's just continue, to the power of 7x minus 3. This was a very long polynomial, guys. By the way, I did polynomials on this channel. If you want to learn about polynomials, you can navigate on the playlist section, and then you will see that I've done a lot of them, right? Integration and differentiation as well. So minus 5 sine 5x, 5 sine 5x, and then the last one is negative 6 over x. Guys, this is a very, very long polynomial. Let me double check. The first term we have 4, and then we have cube root x minus 3 cosec x multiplied by cot. We have 3 tan x. We have negative 2e to the power of 7x, negative 3 negative 3 to the power of 6x, negative t plus 5 sine 5x minus 6 over x. Okay, dx. So this is our polynomial. So we have to integrate this, guys. It's a very long question. I hope you guys can see there, right? So I'm gonna do them one by one. But before you integrate, guys, you need to check each and every term here, whether it is simplified. Remember, if you don't know, guys, you cannot integrate with a SAD. A SAD is basically a root there, guys. You cannot integrate with a root, so you need to simplify this one, the first term. The second term is actually fine. It's tricky, but it's fine. And then the third term is also fine. We can integrate it. The fourth term is fine. The fifth, the seventh, the eighth, and the ninth term, they are all fine. The only term that it needs to be simplified is the first term. So to make your life easier, guys, try not to integrate while you're simplifying. So just simplify, then you will integrate everything all together. So let's do it. So we have 4 there, and then we know that this here is the same as the power of 1 over 3. Guys, whenever you have a square root like this, we know that we change this into exponent. It's going to be the power of half. There is 2 there, there is 1 there. So this 2 is the denominator on the fraction, and the 1 there is the numerator there. So that's why we have x to the power of 1 over 3 there when you simplify it. So from there, we're just gonna rewrite everything as it is. Guys, I know this can be annoying because it takes time, but if you really want to pass or you want to understand what is going on here, do things step by step. Remember, you are a novice, you are learning, so you have to do things slowly but surely. All right, once you get to understand how to do things like a professional, that's when you can start skipping some steps, guys. If you are not, if things are still new, especially most of the things that you're doing here are still new to you, rather do them step by step. So the second step here, guys, it's when we simplify the first term there. Now you need, now number two, what do you need to do here, guys? Because we have a lot of terms here, you need to recognize what integral is each term. For example, I can tell for the each term here, we have 4x to the power of 1 over 3. This is a standard integral. Now, the standard integral, guys, we know that the formula for the standard integral, I'm going to write it here. We have this, x to the power of n, right? And then when we integrate, this is going to be let me just it's going to be x to the power of n plus 1 divided by n plus 1. This is a standard integral plus c, right? So our n is our exponent there. In this case, we also have 4, which is the coefficient of x there. So when we use this formula, when we integrate, because when you start integrating again, guys, you lose the sigma and also the dx. This sigma here and dx, oh, I didn't write it there, but this dx there, you lose them. While you simplify, you keep these two, guys. All right, right. So you're gonna write your coefficient, which is 4 in this case, right? And then you're gonna apply this here, right? So we have x to the power of 1 over 3 minus, oh, plus 1, by the way, right? And then we must divide. Guys, do not confuse integration with differentiation. It's very, very close, guys, right? So let's continue. We have 1 over 3 plus 1. So you must also divide by whatever you did there on our exponents, right? Remember, we add the exponent with 1 with the standard integral. Now let's look at the second term. The second term here, guys, it's tricky, right? I hope you guys have the formula sheet. I do not have the formula sheet with me here. Let me try to add the formula sheet, guys, so that I can show you how to do this one. This is gonna take our time, but I feel like I need to show you guys. Let's add the formula sheet. I hope we have it here. Let's check the other previous question papers. Oh, what's happening? Oh, well, it doesn't agree, guys. It doesn't agree. Let me try another question paper. I was supposed to upload the formula sheet, guys. I don't know what happened. I guess I got disturbed and I forgot. Right, yes. Let's look at the formula sheet. I'm just gonna upload only the formula sheet. Here's the formula sheet. I'm uploading it, guys, right? I'm gonna show you exactly what I want you guys to see there. Look at this here. Before we continue, let's look at our integral here. Do you see this integral here? We have negative cosec x multiplied by cot. By the way, it has the coefficient of 3. So this one there, it is not there on a formula sheet, but it is there in a hindsight, guys. Let me just show you very quickly. Right, remember, when we integrate, we are going backwards. So let me just zoom very, very quickly there. Look at this last part here, right? If you can look at your formula sheet, when you move this way, by the way, we are integrating. Remember, this table here, it's when we differentiate. Look, when we go this way, we are differentiating, right? D is equaling to dy over dx, but we know that integration is the opposite of differentiation. So meaning when you go that direction, we are integrating. So we can say whenever you see negative cosec cot x, you must have positive sec there. Guys, I hope you can able to understand this, right? So I'm gonna erase this part here so that we can able to continue with our thing there. I hope you can able to see this, people. I hope you can able to see this. Let me just move this formula sheet underneath there, guys. Okay, let's move it. Let's move it underneath there, guys. Let's move the formula sheet. There we go. There we go. So I hope you can able to see that. If you didn't see it, you can always rewatch the video, guys. Right? You can always rewatch the video on your on your on your on your on your spare time, right? Because right now we're trying to work against time. So let me just zoom this for the last time to 100. All right. So it means now this is like this. When you integrate, let me just rewrite it here. When you integrate them, remember the one that I highlight with the red line. So we know that the integral of cos sec, right, x multiplied by cot from the table there, guys, right, dx, it should be giving you, if it's negative, it should be giving you positive cosec, right, x. That's it. But now we have the coefficient of 3 there, so this is going to be plus plus 3 cosec x. This is there on your table, guys. It's given to you. It's just that it is not clear how they actually gave it to you. So you have to seek it out from the table, right? So this is how you integrate that one, right? If you have questions based on this, can I answer you later on as we continue here, guys, right? As we continue. All right. So let's look at this one here. We have this term here. Let me erase this. We have the third term, which is tan 3 tan x, right? So 3 tan x. So what is the integral of 3 tan x? By the way, when you integrate the trigonometric ratios, you're gonna have k like this, and then we have tan, right? And then we have n, the coefficient of x, and then we have that. So the integral of this is gonna be k, right? And then what is the integral of tan? If you still remember, tan is natural log sec and then x. Guys, this is there on the formula sheet. Let me just go to the formula sheet so that I can show you guys, right? Where is it? Where is it? Let me zoom it. There we go. Let's go. Let me zoom there. There we go. You guys see it there. So here's the integral of tan there, guys, right? It's actually natural log x plus c. So but basically this is what it is. Whenever you have to integrate tan, this is what you must get there. So I hope you understand, people, right? So let me just go back. Oh, there's so many moving of this thing here. So the k, by the way, is just the coefficient of x, guys. It's just the coefficient of the integral, not x, right? Oh, I forgot, guys. I keep on forgetting some stuff here. Oh, I forgot the following. So when you integrate this, I almost forget this, guys, right? So when you integrate this, it's gonna be k natural log sec n x, and then you have to divide by n. Remember this n here, the coefficient of x, when you integrate this time around, we divide by it. So if you go to our question there, we have 3, which is, in this case, this is going to be our k, natural log sec. We don't have the coefficient of x. Well, the coefficient of x is 1, so it's going to be sec x divided by 1, right? So n is 1 there, that's why we don't write divide by 1, right? So we move to this one here. This is the, let me see, 1 2 3 4. This is the fourth term, the exponential. Now the general formula for exponential, we have k, the coefficient of the base, multiplied by the base, which is a. And then you're gonna have n to the power of x. You're gonna have the power of n, x. N is the coefficient of x, guys, right? So when you integrate this one here, you're gonna multiply with k, which is the coefficient of the base, and then you multiply the base again, and also you keep the n on as an exponent, multiply by x. But this time around, you have to divide by the coefficient of x, which is n, natural log, then the base, right, plus c. So this is how you actually integrate the exponential. And again, how do you know this is an exponential integral? When x here, guys, is the exponent, that's when you know that it is an exponential integral. Remember, for these that we just did earlier, these are just trigonometric ratios, so you can see by the trigonometric ratios, right? So let me erase, or let me continue and do this one. So let's see that, let's try to recognize our k, our a, and our n. Remember, k is a coefficient of the base. When you look at this question here, or this expression here, our base is e. You guys see, because it has the power of 7x, while our -2 is our k. So we have to, when we follow this here, we have to say minus, right, 2, we do, this is our k, multiplied by a, which is our base there, you guys see, and then 7x. But this time around we must divide them, so we must divide by n, which is the coefficient of x, which is this 7 there, so this is going to be 7, and then lean, and then we have the base, our base there, which is our e, so base e. There we go. So guys, I hope you can able to see this. These are general formulas. They are there on the formula sheet, but some things are missing. The coefficient of the base and the coefficient of x, they are missing there. So let's go to another one here. I think this one here, which is this one here, where we have -3 to the power of 6x. Again, this is an exponential integral because our x there is the exponent. So we're still gonna use the same formula. I should have not erased it, guys. So remember, again, when you have k a to the power of nx, right, dx, when you integrate this is going to be y is equaling to k, you multiply by k, you multiply the base and the exponent there with its coefficient, and then divided by n natural log a, right, plus c, right? So here we need to recognize here on this one here, what is our k, what is our a, and what is our n. But it's very, very simple. Look, as you can see, our base here is clear, it is 3, because it has the power of 6x. For the fact that it has the exponent of x, that becomes our base, meaning now our k is just -1, or just 1 there. So when you write this using this formula there, our k is 1 multiplied by the base, which is 3, multiply, oh, to the power of 6x there, right? So divide by, if we divide, look, we're gonna have n there. Our n is the coefficient of x, there we go, which is gonna be 6, you guys see, and then natural log, then what is our base? Our base is 3 there, people. I hope you guys can able to see this. Are we still together, guys? Okay, right. Someone said wait, say there is 5 sine x, not, oh, it's positive. Right, let me double check. The sine x is positive. Oh yes, thank you. Who's this? Gianni. Thank you, Gianni. I almost made a mistake. Yes, it is positive. I fixed it. Thank you, Gianni. Right, so let's continue. Right, let's do this one here, this term there, guys. Look at this. We have -3t, right? -3t, guys, it's the constant. Remember, when we integrate, oh, by dx, when we integrate, guys, we just multiply by whatever the variable is. So when you have the constant, do not confuse this with differentiation. Most people, they will put 0 here. It's not 0, guys. Multiply by x. This -3t, you multiply it by x, and then that you are done. So it's going to be 3t, then x, then you are done, because this is a constant and we are integrating. Now the last one there, we have 5 sine 5 sine 5x, right? So this one here is the one that Gianni helped us with. Guys, I'm reading from Mutlowung. It said, sorry sir to disturb, can you kindly confirm the date for N5? Oh, can I? It's Wednesday. It's Wednesday, Mutlowung, the test for N5. All right, so where are we? We are here on this one here, guys. We are here on this one. So we have to use this formula again. Remember, we have k, the coefficient of the trigonometric ratios. We have a trigonometric ratio, which is sine, and then we have 5, right? Or we have n instead of 5, guys. It's n. We have n x, right? Dx, right? So when we integrate this is gonna be k. What is the integral of sine then? If you still remember, the integral of sine is negative cos, guys. Integrating sine and differentiating sine and cos, it's very, very confusing, guys. I hope you can tell the difference. When you integrate sine, it's going to be negative, but it is there on your formula sheet underneath there, guys. It is there. So you're going to have negative cos n x. All this is divided by n. Remember the coefficient of x there, guys. When you integrate, you divide by 8. When you differentiate, you add, you multiply by 8 plus c, right? So let's do it here. So we can say minus, right? Or let's just say plus to make our life easier. We have 5 here. Our 5 is k, right? This k then. And then we have the integration of sine, which is negative cos, right? 5x. And then we divide by, let's not forget, we must divide by n, which is the 5 there. So it's going to be 5, right? And then we do the last one, minus. Now, guys, when we have 6 divide by, when you have 1 over x, that is also the log integral, but is the natural log integral. Guys, whenever you have something like this, 1 over, or, right, x to the power of negative 1 dx. These are one and the same thing, guys. The integral there is going to be ln, right, x. So this is k. Let's just make it k then. So if the k is a coefficient, you just multiply by k plus c then. So when you look at this one here, we have negative 6 over x, which is resembles this one then. When you integrate, it's going to be k ln x plus c, right? So let me just erase here, guys, and let me just create a little bit of space. We are running out of space there, guys, right? I'm trying to show you all these integrals, guys, right? Trying to show you all these integrals. I hope you guys can able to see them. I'm zooming down, guys, because we're running out of space. But our final answer here is going to be 6 ln x plus c. This one, most people, they confuse it with the standard, guys, right? Again, when you have 1 over x, let me just k over x, or x to the power of negative 1. Guys, remember, when you use the standard, you must say plus, and this is going to give us 0. How are you going to integrate this, guys, right? How are you going to integrate this when you do the standard there? Remember, we're going to have 1 plus negative 1 plus 0. So it's not going to work, right? It's not going to work. Don't use the standard integral whenever you have such a thing, right? So this is the integral, but it is not complete, my good people. It is not complete. So we need to simplify further. So I hope you guys can see them. So let's look at the first term. Y is equaling to, we have 4 there. We have x. What is 1 over 3 plus 1? 1 over 3 plus 1, I think it's is 3 over 4. Yes, it is 3 over 4, right? And then remember, you divided by a 3 over 4. Whatever that you get here, you must divide by it there. Remember, 1 over 3 plus 1 over 3, it gives you 3 over 4 then. And then plus this one here, it's fine the way it is. So it's going to be positive cosec x. And then even this one here is fine. It's going to be 3 ln sec x. And then this one here, let's look at this term here. Guys, I hope you know that when you have ln e, this is 1, right? Ln e, guys, is 1. If you do have your calculators with you, you can check it out. You press ln on your calculator, obviously, and then e, it's basically you press shift on your calculator. Let me see. You press shift. There we go. No, you don't press shift, guys. You press alpha, right? Okay. For E, you press alpha. Okay. then you press this button here, 10 times, x times 10 to the power of x. Then it will give you e on your calculator, guys, right? It will give you e. So you're gonna have this on your calculator. So you press lean, then you press alpha, then you press this button here, x times 10 to the power of x. You'll have e there, and then you'll see the answer is 1, right? But you don't really have to do that. Just know that lean e is 1. So we can rewrite this like that. We can say this negative 2 to the power of, multiplied by e to the power of 7x divided by 7, because this here is 1, right? And then we go to the next one. Now here I tend to have a lot of people who are a bit confused here, guys. This 6 here and that 3, they cannot divide each other. Remember that. The reason why they cannot divide each other is because this 3, it has the power of 6x, while the 6 has the power of a real number. We don't know what 6x is, so you just leave it as it is. This is gonna be 3, right, to the power of 6x divided by 6 ln 3, right? So leave it like that, and then we continue here. This is gonna give us 3 tx, and then let's look at this one here. Let's look at this one here, guys, right? So this one here, look, we have this 5 and that 5 dividing each other. We also have this negative there, you guys see? So meaning this is going to become minus cos 5x minus ln, 6 ln, minus 6 ln x. Oh, we are running out of space, people. We try to create a space again, plus c, right? So this is our final answer. All right, someone said, what did I write, guys? Someone said 1, what did I write, guys? All right, I don't know what's happening. People are asking questions. So let me start with Mshiwa. Is it Mshilwa? I think it's 4/3. No, it is not 4/3, guys. It's not 4/3. It's actually 3/4. You just punch your calculator correctly, guys, right? Punch your calculator correctly. It is a 3/4. Now, guys, this term here, you can rewrite it like this. Now, this one, you can take this on your calculator. You write it as it is there. You say 4 divided by 3/4. And the answer here, I think, is gonna give you it's gonna give you 12/3, which is gonna give you 4. Let me double check, guys. 4 divided by 3/4. This is gonna give us, and we ooh, let's just do it. 4 divided by 3/4. Let's see. The answer is gonna give us, what is happening? Yes, the answer is gonna give us that. Let me see. 3 plus, maybe these guys are right. Are you guys correct? 1/3 plus 1. Oh yes. Oh, you guys are correct. It's yeah, you guys are correct. You guys are correct. It is not 3/4, guys. It is 4/3. Thank you, Sewu, Liton, and Siwa. Oh, thank you guys for correcting me there. I made a mistake here, guys. I hope you managed to see this. This is not that. 1/3 plus 1 is actually 4/3, right? Meaning now we have to change this as well. What is it? This one here. Thank you guys. Thank you guys. I just went back to the calculator and double check. So it's gonna be 4/3. There we go. Yeah, we are fine. We are fine. So if you put that on the calculator, it should give us what we have. We have 4 divided by 4/3. So the answer here is gonna give us 3. We must have 3 there. Okay. All right, so let's continue. We're gonna have 3x to the power of 4/3. There we go. Now we continue there, but you don't really have to change anything here. It is cosec x plus 3 ln sec x minus 2e to the power of 7 divided by 7, or 7x, don't forget the power there, minus 3 6x divided by 6 ln 3 minus 3tx minus 4 cos 5x plus, let me create space, guys. Someone asked whether it's cosec or cos. Can you mention non-clear? Can you mention the term that you're talking about? Are you talking about this term here? This is cos 5x. My handwriting is not good looking, right? It is not good looking. So it's cos 5x. And then, minus, by the way, not plus, minus ln, 6 ln x plus c. Guys, you only put c once after integrating, guys, right? You don't have to put c on each and every term, right? The c, you only put it once at the end of integration, right? At the end of integration, that's where you put your c there, my good people. Are we all together? I'm hoping that we all managed to understand this. It was very long, guys. 9 marks, by the way. If you didn't know, it is out of 9 marks. So all I can say here, guys, is that make sure that you pay attention to the terms. As you can see, the first term is the standard integral. The second term is trigonometric, and this one here you must check on the table there. You go backwards on the table, and then it will give you this, right? And then the third one, it was also trigonometric ratio. It is there on the formula sheet for tan. So this is gonna give you that. And then these ones here are exponents. How do you know? Because x is an exponent, this here, right? And then this one here, it's a standard because we have 3t. We are not integrating with respect to t, we are integrating with respect to x. So if there is no x, it means the constant. So when it's a constant, you just multiply by x, guys, and move on. And then this one here,